Good evening, everybody. Welcome to Tibbetts Physics. What is crappinin'? Today we're going to do some practice problems, actually one practice problem, on analyzing a distance versus time plot. First thing we need to know when doing this is how to find the velocity or speed. So the slope of the graph is equal to the velocity. And if we remember from math class, the slope is the change in y over the change in x. And in this case, your y-axis is distance, so the change in distance, and your x-axis is time, so change in time. So what we'll do is we'll find the slope or the velocity at each interval. So let's look at the first set. We're going from 0 seconds over to 3 seconds. If we look at our distances, it starts at 4 right here and goes up to 10. So change in velocity change in distance over change in time. So V equals delta D over delta T. Delta T. Change, remember, is final minus initial. So it would be final distance, D final minus initial distance, over T final minus T initial. So you've got 10 meters for our final, minus 4 meters for our initial, over 3 seconds minus 0 seconds. 10 minus 4 is 6, so that's 6 meters per 3 seconds. And that gives us a speed of 2 meters per second. Just move myself down more in the corner a little bit. Alright. Let's look at the next interval. So now it's straight from 3 seconds over to 5 seconds. Okay, same formula. Velocity, change in distance over change in time. Our change in distance, well, we end up at 10 meters. And we start at 10 meters, so it's 10 meters minus 10 meters. Over, we're going from 5 seconds and starting at 3 seconds. So 5 seconds minus 3 seconds. 10 minus 10 is 0, 5 minus 3 is 2. 0 divided by anything is 0, so the velocity is 0 meters per second. And that makes sense. If you look at the graph, the person is just hanging out right here. They're not gaining any distance. Time is moving forward, so they're just sitting still. Okay, and let's do it for the last interval of time, from 5 seconds all the way up to 10 seconds. So change in velocity is distance over time. Change in distance over change in time. Delta D, over delta T. Okay, so let's see our distance. We end up at 30 meters, and we start out at 10 meters, and our time goes from 5 seconds over to 10 seconds. So 30 meters minus 10 meters over, I forget the time, 10 seconds minus 5 seconds. That gives us 20 meters over 5 seconds. 20 divided by 5 is 4 meters per second. So the key idea, again, is that the slope represents the velocity. Now, we might also be asked how much distance did this object travel, or what was its displacement? So let's look at the distance. Remember, the distance is the total area covered. So this object or a person started out at 4 meters and ended up at 30 meters. So their total distance is 30 meters minus 4 meters, which is 26 meters. And then displacement is the shortest path from start to finish. In this case, the displacement is they started out at 4 meters, and they finished at 30 meters. So the displacement is still 30 meters minus 4 meters, which is also 26 meters. In this case, we get the same thing. But let's add to the graph to change it up a little bit. Let's say that the person now goes down a little bit. We'll say down to 15 meters. So, distance is the total area covered. So we know that from the beginning, the person started at 5, then they went up to 30, so that was 26 meters. And then the person finished at 15, so they went from 30 down to 15. That's another 15 meters, giving us a total distance of 41 meters. Okay, let's do the same thing for displacement. And let's see if we'll get the same answer as distance. So again, displacement. Where do you start? Where do you finish? It's the shortest path. Oops. This one's still over here. So we started at 4 meters and we finished at 15 meters. So your displacement is 4 up to 15. So 15 meters minus 4 meters. Displacement is 11 meters. And that's how you analyze a distance versus time graph. And that's it for me. Hope you found that helpful. See you next time. See ya.